Okay, we're going to look at one more example here using undetermined coefficients to solve this differential equation. So the reason undetermined coefficients would work well is that we can easily find our YH, recognize that we have constant coefficient differential equation on the left side here, and the non-homogeneous part is all made up of functions where when you take the derivatives of them, you keep getting back the same kind of functions or simpler functions, and that makes a finite list of function types. So we're going to start by finding our YH. This one has a left side that's a little different than the last few, so we will have to solve our characteristic polynomial. So thinking about that we've been doing for a while, our characteristic polynomial r squared minus 4r plus 4 equals 0. So you can see pretty easily that factors into r minus 2 twice, and so you get r equals 2 with multiplicity 2, so twice. So our YH is C1 e to the 2t plus C2 t e to the 2t. Okay, so that's our YH, and then the new thing that we're working on today is making the appropriate guess for the YP. So this is one where we will need to do some modification of our guess, but I want to first talk about the types of functions in your sort of initial guess before you make that modification. All right, so you want to think about these functions that are here on the right-hand side of the differential equation and all of their derivatives. So maybe you do a little scratch work and write out some of those derivatives, but by the time we get to the exam over this unit, probably you should be able to kind of think those through in your head. And again, really you're not worried about the coefficients out front, you're just worried about the function types. So when you think about taking derivatives of t times e to the 2t, remembering that you'll have to use product rule, you'll get e to the 2t terms, and then you will get 2t e to the 2t terms. So you're going to get back this function, and you're also going to get an e to the 2t function out of derivatives of that. And if you just keep taking derivatives of t e to the 2t and e to the 2t over and over again, you just keep getting this function t e to the 2t and more multiples of e to the 2t. So from that part of my right-hand side of the differential equation, I'm going to need these two function types in my guess. Then I also have a t term here, so a degree 1 polynomial. So I'm going to need a t term in my guess. And then when I take derivatives of that, I will just get constant and then eventually 0. So these four function types that I have written down here are what I need in my initial guess. So I have four terms in my initial guess. And that would be the appropriate guess if I did not have any duplication in my YH. All right, but I do. I have both e to the 2t and t e to the 2t that show up in my YH. So that's important to notice. I'm going to have to modify my guess. All right, so we're going to multiply our guess by the smallest power of t that helps us avoid that duplication. But when I thought through the types of functions I needed in my guess, notice that I kind of thought through that by different function types. The exponential functions are just going to give themselves back as we take derivatives of them. So these two functions are sort of based on just that t e to the 2t term. And then the linear term and c, those are kind of based on just the t term. So I really have sort of two groups of terms in my guess here. And when I multiply my guess to modify it, when I multiply it by a power of t to avoid duplication, I am only going to multiply the part of it that comes from the part that is duplicated. So the only part I'm going to multiply by a power of t is this part where we have duplication that came from the functions that are duplicated here. I'm not going to multiply these last two terms by that power of t. So you can handle this way. You can also handle this problem by really treating this like two separate problems and dealing with the t, each of the 2t and all of those guesses and find the a and b. And then you can deal separately with that t term and make that guess and do it that way. I tend to do the problem all together. I think it's probably just more efficient. But the thing to be careful about is that you're really just multiplying this part of your guess by the appropriate power of t. All right, and you want to multiply by the smallest power of t. That will avoid duplication. All right, so if I just multiply this whole group here by t, then I would have at squared e to the 2t, which avoids duplication. But I would have a bt e to the 2t, which is still duplicated over here. So on this one, instead of just multiplying by t, I'm going to have to multiply by t squared, this whole group by t squared. This modifying of your guesses, and particularly modifying just part of your guess by multiplying by a power of t, sometimes takes some practice. So if the first time through a problem like this feels a little challenging, that's okay. Do another one, do another one. It will start to feel more natural and you'll start to understand what's happening here. All right, so this is the appropriate guess. I'm going to cross this other one out so that when I find my A, B, C, D, I make sure I put them back into the right form of my YP guess here. All right, so we need to take appropriate derivatives and substitute into the differential equation. All right, so we're going to have to use some product rule here. So our derivatives are going to be kind of long. All right, so there's product rule for my at cubed e to the 2t. And then I'll have this next term. And then derivative of ct plus d, I'll just get c. So that part at least gets a little bit simpler. And now I need my second derivative. All right, so I got these two terms from my derivative of 3a t squared e to the 2t using product rule on that. And then I'll need another product rule here. I will get some terms that I can eventually combine with some of these here. So all right, and then I will take the derivative of my b terms here. So so lots of derivatives there to be careful about. And I do have some terms here that I can combine as I do that. I'm going to go ahead and plug into the differential equation. We will get a lot of nice simplification when I do that. So when I plug into that differential equation, I'm going to combine those terms kind of as I do that. All right, so for the y double prime, and let's see if I can combine my terms correctly here. I might cross some of them off here as I do that. So for the y double prime, I'm going to put my terms in descending order of degree as I substitute in. So I've got a t cubed term, t cubed e to the 2t. And I'm going to mark that off. Not that it canceled, but just so I know I already took care of that. I've got a couple of t squared e to the 2t, 3 of those here. So 6a, 6a, oh, there's a 4b there, so I can't really combine that. But 6a plus 6a, so 12a. And b, 4b. And then t e to the 2t terms, I've got a 6a, and it looks like that's it for the a's. And for the b's here, I'll have an 8b t. and plus 2b e to the 2t. All right, all that is my y double prime. Thankfully, these other ones are a little shorter. Minus 4 times y prime. All right, so again, I'm going to group some terms together here. I'll put them in descending order of degree. So 2a t cubed e to the 2t. And then I've got a couple of t squared e to the 2t terms here. All right, and then a t e to the 2t. And a c. And then plus 4y. A t cubed e to the 2t plus b t squared e to the 2t plus ct plus d. And all of that should equal my right-hand side of the differential equation. All right, and this looks like a giant mess. But when you have these duplications, you should expect that when you substitute in, you will end up with some cancellations. If you don't, that's a time to go back and look through your work and make sure you don't have a sign error somewhere. All right, so let's look for what cancellations I have here. I have a 4a t cubed e to the 2t and a minus 8a t cubed e to the 2t and a plus 4a t cubed e to the 2t. So those terms all add up to 0. A plus 4 and a plus 4 and a minus 8. Those all add up to 0. All right, let's look at our t squared e to the 2t terms here. I have got a 2a t squared minus 12a t squared e to the 2t plus 12a t squared minus 12a t squared. Yep, those canceled. 12, I thought that was a 2. But 12a squared and a minus 12a squared, so those cancel as well. We've got some bt squared e to the 2t terms. So let's see, I've got a plus 4bt squared here and a minus 8bt squared and a plus 4bt squared. Those all canceled. All right, and now I think we're down to maybe some terms that don't cancel out and we can use to figure out our coefficients here. So, all right, I've got t e to the 2t terms here. And so on both sides of the equation, I've got t e to the 2t terms. So I have a 6a coefficient and an 8b coefficient. And a minus 8b. I guess these ones do cancel out. A plus 8b t e to the 2t minus 8b. But I have a 6a t e to the 2t. And that should equal my coefficient over here, which is 1. All right, and then I've got e to the 2t terms. I have a 2b e to the 2t here. And then on the right-hand side of the equation, I don't have an e to the 2t term, so 0. I have a t term on the left-hand side of the equation. I've got plus 4c for my t term, and that should equal 1 t term over here. And then I have some constant terms. I have a minus 4c and a plus 4d. What do we say here? Minus 4c plus 4d, and that should equal 0. Okay, so pretty straightforward to solve this system. We get a equals 1/6, b equals 0, c equals 1/4, and once I know c, I can find d. So c is going to be equal to d here, so d will also equal 1/4. All right, so then that allows me to find my yp solution here, And then we can put together our YH and our YP and write our general solution. I'll just put that kind of right here in the middle, I guess. General solution. Y equals the YH plus our YP, the modified guess with all of our coefficients in the right places. So 1/6 t cubed e to the 2t. I don't need to write the b term since that coefficient is 0, plus 1/4 t plus 1/4. All right, if you can get through one like this, you can get through any of them. So try some in the homework. There's a few near the end of your My Math Lab homework on this section where you have to make these modified guesses. So if you're struggling, you get false equations or systems of equations that can't be solved, or you end up with coefficients where you have nothing to set equal and you can't figure out what the coefficients are, it's probably because your guess is not modified correctly. So you can send me questions on those if you have them, and I'll try to help you out with whatever might be messed up in your work.